At first light, the hill looks harmless. A broad, dark rise in the trees, its top sheared flat, its sides falling away in long vertical seams as if the earth had cracked while cooling. Mist hangs in the cuts. The trunks of pines stand around it like younger things around something older and dead. In old survey photographs, before the roads arrived and the parking rails were driven in, the same shape appears with even less disguise. A blunt cylinder, a table of stone, a wound where a crown should be. It is called a mountain, a butte, a volcanic neck, an erosional remnant. Yet when you stand close enough to touch the face of it, the ordinary words begin to sound too small. What exactly are we looking at when a hill rises like a severed column from the land? The accepted explanation is straightforward. Flat-topped hills, mesas, buttes, plugs, necks, monadnocks, and towers belong to known geology. Soft layers erode. Hard layers remain. Magma cools underground and is later exposed. Sediment hardens into rock. Wind and water remove what is weak and preserve what is dense. Over long spans of time, landscapes become selective. They pare away slopes, expose columns, isolate cliffs, and leave behind forms that can appear deliberate without ever having been designed. The timeline is vast, the mechanisms are familiar, and in most cases the explanation works well enough. Geology has names for nearly every shape. A catalogue exists, a sequence exists. The official explanation is not absurd, it is in many places persuasive. But some formations do not merely look unusual, they look specific. They resemble one another across distance, climate, rock type with a precision that starts to feel less like coincidence and more like repetition. A raised cylinder with a flattened top, vertical fluting down the sides, a banded outer skin, a broad root-like spread at the base disguised by debris and later growth, sometimes a ring or shelf where a cambium might have been, if stone could remember wood, sometimes a summit surface that appears less broken than cut. The problem is not that geology cannot produce strange shapes. It plainly can. The problem is that certain shapes seem to imitate the anatomy of a trunk so directly that the explanation begins to feel descriptive rather than sufficient. It tells us what the object is called. It does not settle why the pattern is so exact. So the hidden theory, stated carefully, that is this. Some landforms identified as natural hills or erosional remnants may in fact be the lithified bases of organisms so large that later civilization reclassified them as geology. Not all hills, not every mesa, not every tower, a narrow class of them. The theory does not require a world of fantasy. It requires only that the boundary between biology and geology may once have been less stable than the modern record assumes. If there were giant arboreal forms in a different atmospheric, gravitational, or ecological regime, and if those forms mineralized, fractured, and were later mapped as stone, then the landscape itself would preserve a history no archive intended to keep. The stone remembers. What changed was the explanation. Begin with shape. And across several continents there are isolated rises that share the same blunt profile. Steep outer wall, elevated disc, radial cracks, and a surrounding field of lower material that appears stripped away. In ordinary geomorphology, this can result from differential erosion. Hard-cap rock resists, soft layers disappear. But resistance alone does not explain why some profiles appear cylindrical rather than stratified, why the sides run in vertical pleats instead of slumped terraces, or why the top surfaces sometimes look planed instead of weathered. In aerial photographs, some of these formations read less like hills than like sections. Cross-sections. They appear as if an upright body once extended higher and was removed. If a single example looks suggestive, it could be ignored. When the same geometry appears again and again, the question becomes harder to dismiss. The pattern does not disappear. Measurements deepen the unease. Many of these formations present ratios that feel structural rather than random. Height to diameter, outer wall angle, repetition in column spacing. Even the fracture lines can appear less like chaotic breakage than like stress relief in fibrous material turned to stone. In some sites, the summit diameter remains broad compared with the taper below, producing the visual effect of a cut surface over a narrowed shaft. In others, the exterior exhibits long ridge channels that resemble weathered bark more than simple basalt columns. Geologists would answer that fracture geometry follows cooling, pressure release, and mineral composition. That is true as far as it goes. But when a form satisfies a geological explanation and still retains an anatomical resemblance too precise to ignore, what matters is not whether one language can describe it, but whether another language explains more of it with less strain. Old photographs make the problem sharper because they preserve the landscape before protective myths fully settled over it. Early expedition images often show these formations stripped of modern context. No visitor centre, no signage, no paved approach, just the object itself, emerging from scrub or forest with an almost indecent clarity. In some photographs, the lower slopes appear buried beneath debris fans, as if the visible hill is only the exposed upper portion of something larger below grade. In others, our trees cluster in a ring around the base in ways that resemble secondary growth around a dead core. There are images where the summit surface appears unnaturally level, not with the chaotic rubbling expected from collapse, but with a broad, stable plane. The record is still there. Before the interpretive panel tells you what to see, the image can still ask its own question. Maps add another layer, not the maps printed for tourists, but cadastral surveys, military charts, mining maps, timber records, and early topographic sheets. What they reveal is not proof of giants, it is something subtler and in some ways more interesting. Certain formations treated as isolated curiosities sit within broader patterns of radial drainage, ring depressions, spoke-like ridges, and satellite mounds that suggest a once coherent biological or structural system rather than an accidental assemblage of leftover stone. Around some flat-top rises, the surrounding terrain appears scoured, as if material was stripped outward from a centre. Around others, there are circular changes in soil, vegetation, and water retention that do not align neatly with simple sedimentary boundaries. Officially, these are ordinary geomorphic arrangements, but when the map begins to echo the same central form as the land itself, coincidence becomes a thinner refuge. Then there is the matter of texture, not the grand silhouette seen from miles away, but the close surface where explanation should become more secure. Visitors to certain towers and buttes describe ridged outer skins, deep grooves, flaking plates, and patterns that resemble bark, vascular channels, or growth stress. Of course, resemblance is dangerous. Human beings are pattern-making animals. We find faces in clouds and intention in ruins. Yet texture is where many official accounts become surprisingly evasive. If the sides are columnar basalt, why do some columns appear fused, warped, or layered in ways that read less like cooling prisms and more like compressed fibers? If the outer face is sedimentary, why do some surfaces present sheath-like peeling rather than clean bedding? The mainstream answer is weathering, mineral variation, and fracture inheritance. Sometimes that is enough. Sometimes it sounds like a list of effects without a convincing original form. To be fair, the mainstream explanation deserves its strongest case. There are landforms whose volcanic origins are well studied. There are cores of ancient magma. There are cooled columns, igneous intrusions, hard-capped rocks, and erosional remnants with dated mineral histories. No serious investigation can ignore that. Some formations invoked by giant tree theorists are almost certainly geological in the conventional sense. That matters because it prevents the theory from becoming a catch-all fantasy. But fairness cuts both ways. A correct explanation for some examples does not automatically resolve every example. Classification often expands by analogy. One prominent tower is identified as volcanic, so visually similar towers inherit the label. One flat summit is erosional, so the next flat summit becomes another remnant. The question is not whether geology explains many of these places, it plainly does. And the question is whether it explains all of them, especially the ones whose details refuse to sit comfortably inside the category. Engineering records are strangely revealing here, not because engineers set out to solve hidden history, but because they describe material behavior without caring about mythology. Quarry reports, road cuts, blasting notes, and foundation surveys sometimes describe stone masses that do not fracture as expected for the rock they are supposed to be. Unusual toughness, fibrous break patterns, layer transitions that resist bedding assumptions, outer shells harder than inner cores, or the reverse. In some cases, workers remark on concentric organization, internal voids, or ring-like transitions. These notes are usually filed under local variation, anomalous material, site-specific irregularity. But when one reads such records across regions, a faint pattern emerges. Some of these hills do not behave like simple blocks of cooled magma or uniform sediment. They behave like composite bodies. The language is technical, cautious, buried in appendices. But it is there. Legal and institutional records tell another story, and perhaps the most human one. Once a landform enters a category, the category becomes self-protective. A hill designated as a geologic monument will be studied geologically, funded geologically, described geologically, and defended geologically. Museum labels, school textbooks, park signage, and grant language all reinforce the same frame. This is not a dramatic conspiracy. It does not require secret committees hiding the truth in locked vaults. It requires bureaucracy, professional incentive, and the inertia of accepted definitions. If a formation might be both geological and something stranger, the system has no good place to put the second possibility. It falls outside discipline. It sounds unserious. Careers are not built by confusing categories. What remains then is not suppression in the theatrical sense, but a narrowing of what experts are allowed to notice. The scale widens quickly once you stop looking at a single site and start comparing forms across the world. Isolated towers in the American West, flat-topped mesas in desert belts, table mountains with abrupt sheer walls, circular plateaus with ring fractures, columned pinnacles emerging from forests half a world apart. They differ in rock type, climate, and age assignment, yet certain visual features recur with unnerving consistency: broad top, vertical sidewall, peripheral debris, occasional radial cracking. Sometimes a resemblance to a stump burned, cut, and left to harden. Geological convergence is real. Different processes can produce similar outcomes, but global repetition has a double edge. It can strengthen the mainstream account, or it can expose a larger biological or environmental pattern no one has seriously modelled. The pattern repeats. Once seen, it becomes difficult to unsee. There is also the problem of missing infrastructure. Natural hills form within landscapes that usually preserve the logic of their making. If erosion isolated a remnant, where is the expected volume of removed material? If a volcanic core stands exposed, where are the consistent peripheral signatures of the larger system that fed or enclosed it? In many sites, such traces do exist. In others, they are curiously incomplete. The surrounding strata look rearranged, stripped, or mismatched. Drainage lines veer as if responding to buried geometry. Soil depth changes abruptly around the base. Vegetation forms rings not easily explained by simple elevation or shade. These are not dramatic clues. They are the sort of details field workers notice and then set aside because no standard model requires them. Yet hidden histories often survive in exactly this way. Not as one impossible fact, but as 100 small mismatches between the thing and the explanation attached to it. Historical timing makes the silence more conspicuous. Many of these sites were named, mapped, and institutionalized during centuries when geology was consolidating its authority and earlier cosmologies were being aggressively cleared away. Indigenous traditions, as settler folklore, mining speculation, biblical chronologies, and emerging scientific geology all competed to explain the land. In that transitional period, descriptions could be surprisingly unstable. A feature might be called a castle, a tower, a tree-like rock, a petrified form, a volcanic remnant, and a monument within a few decades, depending on who was writing and why. Over time, the language narrowed. That is what disciplines do when they mature. They remove ambiguity, but sometimes ambiguity disappears faster than evidence warrants. An old surveyor records a trunk-like appearance. A later report omits it. A local story about a petrified giant forest becomes folklore, then embarrassment, then nothing. What changed was the explanation. The theory becomes more interesting when placed against older ideas about petrification. For much of history, the transformation of living material into stone was not exotic at all. Petrified wood, shells in mountains, bones turned mineral, entire forests silicified. These were visible facts long before modern chemistry clarified the process. If small biological structures can mineralize so completely that they become stone, the real objection to giant trunks is not petrification itself, it is scale. We are willing to grant stone memory to a log, but not to a mountain. Yet scale is exactly where the modern imagination often fails. Ancient ecologies already include enormous ferns, towering fungi, giant insects, immense reptiles, and atmospheric conditions unlike those of the present. The further back the record goes, the stranger life becomes. So the relevant question is not whether petrification is possible. It is whether our present scale limits have quietly dictated what evidence we are permitted to recognize. Consider the recurring geometry of cut surfaces. In some formations, the summit is not merely flat in the casual sense. It is broad, abrupt, and bounded by a clear edge like a severance plane. Weather acts unevenly. It rounds, pits, slumps, undercuts, and shatters. But a cut, even an ancient one, leaves a different impression. There is a finality to it, a change of state. At certain sites, the top appears less like the last surviving layer of a hill and more like the exposed end of a vertical body. Geologists answer that caprock and jointing can create exactly such surfaces. Again, sometimes they can, but the eye keeps returning to the same anomaly. The top does not merely sit there, it seems to terminate something. That is why the stump comparison persists, even among people with no interest in forbidden history. The image arises spontaneously because the form keeps proposing it. Eyewitness descriptions from travelers, surveyors, climbers, and local residents are not scientific proof, but they reveal how stubborn the visual analogy has been across time. Again and again, long before internet theories or algorithmic communities, observers describe certain hills as chopped, sawn, truncated, bark-like, tree-shaped, stump-like, root-bound. Some use the language casually. Others seem almost irritated by it, as though the resemblance is too obvious to trust. These accounts matter not because witnesses solve the mystery, but because they show that the same perception recurs independently. If the stump analogy were merely a modern fantasy imposed on the land, but it would not appear so consistently in older descriptions produced under different assumptions. Language leaves fossils too. The record shows repeated attempts to say the same impossible thing in ordinary words. One of the strongest objections is scale, and it should not be brushed aside. If these were trunks, where are the branches, the crowns, the leaf systems, the associated forests? Where are the roots large enough to match them? It is a fair challenge. But erosion is selective, burial is unequal, and classification is never neutral. In a world willing to misread a trunk as a tower, it could also misread roots as ridges, branch scars as canyons, collapsed crowns as mesas, and petrified groves as badlands. Once a biological form passes beyond accepted size, its parts begin to migrate into separate disciplines. One piece becomes geology, another becomes hydrology, another becomes paleobotany, another is too degraded to classify at all. The object is not hidden in one place, it is dispersed across categories. That is why it remains invisible even in plain sight. There are landforms where the base seems more revealing than the summit. Around some flat-top rises, the lower perimeter spreads in buttressed flares or radial protrusions partly buried under later sediments. They are usually treated as talus, old flow fronts, slump masses, or resistant outwash. Yet the visual logic often suggests support structures rather than deposits. The lower body appears to thicken as if to carry load. In biological terms, this would be expected. In geological terms, it must be explained case by case. What matters is not any single interpretation, but the recurrence of basal geometry that resembles anchoring more than accumulation. If a tower stands alone, geology is enough. If that tower repeatedly stands on a buried, flared foundation suggestive of roots or buttresses, the question sharpens. The hill begins to look less like leftover land and more like the remaining core of something that once rose far higher. At this point, the hidden theory sounds strange because it rearranges the order in which we are taught to see. We are told first what the object is, then invited to admire how well the label fits. The investigative approach reverses that. It asks what the object looks like before explanation settles over it, how it behaves under measurement, how it sits on the map, how it fractures, what earlier witnesses called it, what institutions later erased from the description, and whether similar forms repeat too precisely to dismiss. This does not prove that hills are giant trunks. It does something more unsettling. It reveals that the official account often depends less on exhaustive resolution than on category confidence. Once a thing is named, attention relaxes. The mystery is not solved, it is managed. Economics also matters. Landforms are resources, monuments, protected sites, tourist assets, mining hazards, and legal parcels. Their meaning shapes budgets. A volcanic neck fits signage, curriculum, and risk management. A possible petrified biological megastructure does not. It would raise impossible questions about chronology, paleoecology, extraction rights, indigenous histories, and the reliability of earlier surveys. Institutions do not hide such possibilities because they are sinister. Hence, they avoid them because the administrative cost of uncertainty is too high. Funding follows stable models. Preservation law follows recognized categories. Public interpretation follows approved consensus. In that environment, the strange does not need to be censored. It only needs to be expensive, inconvenient, and professionally embarrassing. Bureaucracy can bury a question more effectively than secrecy ever could. And yet, for all the inertia, the landscape keeps presenting the same provocation. The flat top, the vertical seams, the ringed base, the bark-like texture, the radial drainage, the truncated profile. The repeated language in old descriptions, the material anomalies in technical records, the global recurrence of forms too similar to ignore and too scattered to fold neatly into one local process. None of this compels belief. But disbelief is no longer effortless. Once enough pieces accumulate, skepticism has to work in both directions. It must test the hidden theory, yes, but it must also test the comfort of the official one. Why do certain explanations persist? Not because they answer every detail, but because they prevent larger questions from forming. Perhaps that is the real disturbance here. Not the idea of giants in the fairy tale sense, but the possibility that Earth once supported forms of life or growth systems so vast that later observers could only understand their remains by turning them into scenery. A forest scaled beyond memory would not survive in legend as botany. It would survive as topography. Children would picnic on it. Engineers would blast through it. Tourists would photograph it at sunset and call it a butte. The original meaning would not vanish in a single act of concealment. It would erode the way landscapes erode by slow reinterpretation. The body becomes the hill becomes the monument becomes the unquestioned fact. The stone remembers even when the language does not. So when you see one of these formations again, one of those impossible hills that rise from the land like severed columns, look past the label for a moment. Look at the edge where the summit ends. Look at the grooves on the face. Look at the way the base spreads and disappears under younger ground. Look at the old photographs before the fences. Look at the maps that widen the shape into a system. Look at the records that describe the material without meaning to confess anything. Then ask the smaller, more dangerous question. Well, not whether every mountain is a stump, not whether every strange rock conceals a forbidden past. Only this: how many things in the landscape have been explained just well enough to stop the investigation? Because that may be the deepest pattern of all. A familiar object presented with such confidence that its strangeness goes unexamined for generations. A category placed over a mystery until the mystery hardens beneath it. A landscape interpreted so completely that no one notices how incomplete the interpretation really is. The official explanation may not be false, it may simply be narrow. And if even a handful of these hills are not hills in the way we have been told, then the issue is larger than geology. It touches history, biology, classification, and the quiet machinery by which whole possibilities are excluded from reality. And the pattern does not disappear, it only waits for someone to see it whole. The real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.